recording.
Okay, I've started. Yep.
All right. Well, welcome everybody. My name is Mike Wallach. I am the flight director here at Montana State University for the Borealis program and one of the co-Is on the NEBP project. Just a little bit of background that's kind of relevant for what we're going to do here today. So I'm a private pilot, ultralight pilot, and I fly a thing called a powered paraglider, which is in the pictures on the right-hand side of your screen. And I also carry a reserve parachute with me that I pack myself. So it's a human rated reserve parachute. So if things go south when I'm out flying, I don't fall to my death, I can chuck this thing out and land. And about a year and a half ago, I did a parachute repack clinic for manned parachutes. And in the process of doing that, I realized, why are we not packing the parachutes on our balloon payloads? So historically, we would launch our balloons with the parachute hanging underneath the balloon. It was the top of our payload string. And then after we cut down or the balloon popped, the parachute was guaranteed to open. But for the Eclipse payload, when we added the vent system onto the bottom of the balloon, it sort of negated the ability of hanging the parachute because we'd have the weight of the vent bouncing around on top of the parachute, which we knew from experience was going to tangle everything up. And so we experimented with a lot of things, and then finally decided to transition to a packed parachute system that is built on the same packing system that we use for manned parachutes. So everything that we're doing with these parachutes are the same things for human-rated parachutes. So we're going to cover two topics today. I'm going to cover parachutes, and then we'll go over the camera system. So this is everything other than the Raspberry Pi. So the 360 cameras and the still DSLR cameras. And I'll share all of our camera settings and all that information with you. And then you'll also have access to the PowerPoint slides after that as well too. And then we'll have an open forum session at the end with whatever time we've got left. And that can serve as a catch-all. I am familiar with most of the payload systems in the NEBP string. I'm not an expert on every single one, but we'll try to answer any questions that you might have on that. So getting into just the rationale and the process. So we talked a little bit about why we switched to the packed parachute. And we were having, I would say, about 50% success rate initially as we were experimenting with the NEBP string in our parachute setup, where we're having parachutes getting tangled up. They were opening, but they were tangling up after cut down. And for those of you that have been ballooning for a while, you realize cut down is a pretty violent process. There's a lot of shock load on the lines. Everything falls very quickly. So what we've done is created a bundled parachute that sits inside what we refer to as the diaper, which is just a little nylon package that the parachute sits in. And looking at video from flights where we've flown this thing, we can actually see the parachute punching through a bunch of tangled lines and then opening clean on the other side. And that's exactly what this is designed to do. So the same parachute that I use as a reserve parachute on my paramotor is designed to do the same thing. It holds the parachute together and bundled until it can punch its way through the tangled mess of lines that you inevitably have, and then slowly open and unfold and deploy clean. So far, we have not had one of our packed parachutes fail, which has been pretty good. And we've had our interns experimenting with whether or not we bundle that parachute inside of a diaper that we then lose, because initially that's what we were doing, or actually retaining the diaper with a piece of line that would keep the diaper from flying away. So we do have an instructional video. So this isn't really intended to go through how to pack your parachute. It's more of a some of you have a hot mic out there. Sounds like Randy, maybe.
Sorry.
No, you're okay. So we do have an instructional video. I do have the link here in the PowerPoint slides. This is also linked off the NEBP learning site that walks you through the process of how to fold the chute and how to pack the chute. And if you're going to do that, do it exactly how we have it in there, right? So even if a step might seem unnecessary to you or unimportant, it really isn't. Like I said, there's no difference in how we're packing this compared to how manned parachutes are packed. We're using the same technique. Why reinvent the wheel? Like it works for human rated stuff. It should work well for our parachutes. So, a couple of key things. doing that S fold of the parachute at the end and doing the S fold of the lines. I'll show you some examples of that and some pictures. And just really taking your time to do this and make sure that it's packed clean, and it should open every time. So in aviation, we have a motto of doing everything the same way every time, right? Not deviating from it. And I highly recommend you do that with all things that you do aviation related in the ballooning world. Do everything the same way, do it the same way every time, and you're going to set yourself up for success, right? So here you can see that S fold of the parachute itself, right, where you're going to fold the parachute back and forth. It does get a little bit difficult. You have to kind of have your hands in there to keep it from sliding around. I will tell you, compared to a human rated parachute, these balloon parachutes are a lot easier to pack. Our interns gripe with me all the time that the diaper is too small and you can't fit it in there, but you really can. My human rated parachute is actually not that much bigger when it's packed than what we're flying here for ours. But my parachute is probably about 5 times the size of the one that you're packing. So it just takes a little bit of time, being neat, being careful, getting all the air out of everything, but you can pack it and fit it pretty tightly into that diaper. Right. Again, so these are examples. These are pictures of human rated parachutes, but I wanted to put them in here just to show you the pinning that we do and the S-coiling of the lines. So you can see how all the parachute lines are sort of wrapped in an S-coil, and then rubber bands are gently placed over the tips. And those rubber bands are intended to break off as the chute opens, okay? But it keeps the lines from tangling until the chute opens, and then they break away. The important part, though, is looking at, and I don't know if you can see my pointer when I point at the screen, but where your lead lines come through the rubber band that holds the diaper together. Right, so the diaper all comes together. You have a rubber band that comes out from inside the diaper, and then your parachute lines actually pin the diaper shut. So once there's tension on that, that rubber band is going to break free. So to test this, you really just want to be able to hold the parachute lines in your hand, let go of the diaper, and that should be enough force to pop that pin loose. So you don't want that rubber band extremely tight. It does need to be able to pop away. Okay, I'm going to jump over to camera systems, and then I'll stop at the end for any questions on either topic. This next section will go a little bit quicker. I just want to talk about some of the things that we found flying cameras over the years, some of the problems that we've run into, and some of the solutions that we found. So the first one, the Insta360 camera, all of the teams were supplied with these. The biggest issue that we run into with the Insta360 camera is if the battery dies, it'll corrupt the last file that it was recording. So the Insta360 does break the video up into smallish chunks, but they're fairly long. I think it's 20 minutes per chunk. And if it's recording and the battery dies, it corrupts that last file. It's really hard to uncorrupt them. I know a few teams have managed to successfully uncorrupt the files by using some third-party software. In our experience, the recovery of the corrupted files is pretty poor. So the key is not letting your battery die. So the battery that comes with the camera is not going to be long enough to survive for an entire balloon flight. So we actually use an external battery pack, just one of these USB battery packs that can plug into the camera. That way we have extended battery life. So that combined with having a really large SD card in the camera, so it can record. We've been able to record flights all the way from the ground up to altitude and back down again. The second issue with the SD cards is that, with the cameras, is that they will overheat. Again, for those of you that are new to ballooning, you think the cold would be the biggest problem because you can hit temperatures of 40 below, but it's actually overheating because of the lack of atmosphere. Things get hot. There really isn't enough air to pull the heat away, and you'll have more trouble with stuff overheating. So you'll notice everything that we 3D print is in white plastic for that reason, because we're trying to keep everything as cool as possible. And the same thing goes for the cameras. If they get too hot, they'll overheat and they'll shut down on you. So our interns have some 3D printed files, which I believe are on the engineering site that we use for our camera and for our external battery. On the DSLR cameras that we fly, and again, this is something that we personally fly as a team. You were not supplied this as part of the NEBP package, but for those of you that want to take some nice still pictures during flight, we fly a digital camera, and we use what's called an intervalometer, which is just a little external device that plugs into the camera, and it'll take a picture every few seconds or every few minutes, however often you want to be able to take pictures. And it's just, you just need to do a little bit of math, figure out how many pictures you can fit on your SD card, how long you're going to fly for, and how much of that flight you want to be able to capture pictures of. We usually try to set it up so we can get pictures all the way up and all the way down, so that way we don't miss anything. It does take a little bit of trial and error to get your timing down. But the biggest thing is going to be the camera settings. So one of our interns, her name's Kendall, and Kendall she owns a professional photography business on the side, and she's interned with us for the last year. And so she took over all of our still picture taking, and she's really worked out what settings work well at altitude. Again, because you have a lack of atmosphere, the lighting conditions are very different. And I will say, and this was really cool, Kendall actually reached out to an astronaut who had done a lot of photography on the International Space Station. And not only did he get back to her with all the settings and whatnot that he used, but he connected her with another astronaut who had also done a lot of space photography. So I'm really confident in what Kendall has on here. She did a really nice job of working with this last summer. So she shoots in manual mode. ISO is set to auto. The shutter speed is 1/1000th or faster, and she does say to play around with that a little bit on the ground. You want it fast enough so you don't get motion blur. The white balance is at 5500K. We shoot in RAW format with image stabilization on and an f-stop of f8. So again, you'll have access to these slides, but that's gold right there, that information. Having that information and being able to set your cameras up so that you can get some really good pictures. All right, so that's all I have for information, but I wanted to open up the floor just to any questions you all may have on either the parachutes or the camera. And then at the end, after Janie has done her presentation, we can have an open forum for any questions sort of beyond what we've talked about here today.
Hello, Mike. This is Jason. A lot of the pictures we took during the annular eclipse, it just looked washed out. Like you couldn't tell that an annular eclipse was taking place because it just kind of filled in the entire shape of the moon. Do you have any filters on your cameras or any recommendations?
Yeah, fantastic question. That we had the same conversation after the eclipse. We had some really amazing pictures, but they looked like any other flight, right? You couldn't really tell that there was an eclipse. So we've had a lot of debate since then as to what to do. So our plan for the total eclipse is we're actually going to put some solar filters on some of our cameras, and we're going to leave them off of others. We've had some people say like, well, the total eclipse is going to be different during totality. You wouldn't want any filter on the camera because you're not going to see anything. And then we've had people say like, well, it's not going to matter. You need the filter on there. So I've been doing this long enough to know that sometimes the experts are not correct, and we just need to try stuff ourselves. So we're going to fly both with solar filters and without. So I just bought a solar filter recently off of Amazon. It's about $50, so not terribly expensive for the camera. And then for the video cameras, our interns are trying to, they don't really make, like Insta360 doesn't really make a solar filter for their camera. So our interns are going to experiment and try to build their own solar filter. So but we'll see what we have for results there. But yeah, if you have the payload capacity and you can do some with and some without, that could be kind of interesting. Like I said, I just don't know. I've had people tell me that it's going to work, and I had people tell me it's not going to work. So
Yep, that's good advice to have a mixture of both on the payloads.
yeah, I
Hey,
mean,
Mike,
no, go ahead.
how many cameras are you flying?
We're flying 3 balloons. We're doing 2 vented latex, and we're doing 1 zero pressure balloon. We'll have cameras. We'll have an Insta360 on each of those balloons. That's 3 Insta360s. And we only have 1 DSLR camera, I believe, that we're going to fly. We had 2, but I think we broke 1 last summer. So I think we're only flying the 1. And then I don't know, we have a bunch of GoPro cameras as well too that we'll occasionally fly. So if we have the space, maybe we're going to throw those on there. But I believe it's just going to be the 3 DSLRs and then the I'm sorry, the three Insta360s, the one DSLR, and then I think we're also going to run a Raspberry Pi payload with no. We'll be streaming video on 2 of the balloons, but on the zero pressure, we're just going to record locally. So we'll have a Raspberry Pi just recording video, and we may do a filter on that one as well too.
Yes, sir, Mike. What was the orientation of your Insta camera with reference to paracord? Like it's about 1 feet away or 2 feet away or 3 feet away, and how you orient? Like you focus the balloon, or you focus the ground, or you focus the side?
Okay, good question. So
I saw your beautiful video on a social media. Like somebody chasing the balloon and taking a video. Looks like that.
Yeah, so what we're doing, and this is a little bit new for us. So historically, the Insta360 was in the payload string, and it was probably about 2 feet away from the payloads. So strings came down from a payload box to a 3D printed.
But I saw your video that it looks like a complete structure. I can see from top to bottom with that.
Yeah. So so historically we had it in the payload string. On the Eclipse, what we did is we stuck it on an arm that stuck out about 3 feet away from the payload string. And with the Insta360, it'll automatically remove the selfie stick, right? So if you have a stick coming out the bottom of the camera will remove that. So you won't see, so it gives the illusion that you're floating alongside the balloon, and you can't see any of that support structure. So that's our plan for this Eclipse as well too. We're redesigning it a little bit. I have some interns that are making some 3D prints to hold it, but it's just going to be about 3 feet of carbon fiber rod, and then that'll connect to the 3D printed mount that the camera sits in, and that'll put the camera about 3 feet, just kind of sticking off to the side. And that's how you get those really cool shots of the entire payload string. And it'll be towards the bottom of the string. It'll be one of the lowest points in the payload string.
Thank you.
The cameras with the solar filters are like it's not going to be picking up anything but the Eclipse, right?
Correct.
Okay, yeah. I couldn't quite remember.
So you put the solar filter on a Insta camera?
Well, that's what we're going to try to do. We have some interns that are trying to fabricate something. They've been making some 3D prints with some pieces. I think on the 360s with the solar filter that we're building, we're going to lose a little bit of the 360 view just because of the structure that we're trying to build to hold the solar filters. Because the solar filters are flat, where the 360 camera really has this massive field of view. So I think we're going to give up a little bit of field of view in exchange for being able to get a filter on there with the hopes that we capture some video of the transition. So even if we were to lose everything when we're at totality, we'll still have the transition to totality and then going away from totality. And I think that would be really cool to capture.
Thank you.
Yeah. Okay, any other questions from the group before we turn it over to the next presenter?
Hey, one more question for parachute.
Sure.
So which parachute you are suggesting better, with the parachute having a hole in a center or without hole in a center?
Yeah, so the parachutes that we fly have the hole. Actually, correct me if I'm wrong. I know Randy's listening in there, and he can probably peek in the lab. Ours, I believe, have the hole in the top. The reason for the hole on parachutes, for those of you that aren't familiar, as you're coming down, what happens is air will burble out of that chute, and it'll roll to let the burble of air out, and then you can induce an oscillation into the parachute. So the hole in the top keeps that air from building up and burbling out, so it stabilizes your descent. It also is going to increase the speed of your descent to some extent, but the parachutes that we selected for the NEBP, they're sized for the payloads that we're carrying. So what you should be seeing for a descent is about 5 meters per second at landing. You're going to descend faster than that as you're in the thinner atmosphere, but as you come down towards the ground, if you're monitoring the tracking website and you're looking at your descent profile, you want to see about 5 meters per second at landing. And if you are, then you have everything sized correctly for the size of the parachute that you're using. But yes, preferably you want one with the hole in the top.
Mike, you're correct. The ones that we supplied, it's a SpaceX design that has the hole in the center.
Yeah.
Okay, thank you.
All right.
It's a
Well,
7
great.
feet diameter, right?
Sorry, was that you're asking about the diameter?
Is it 7 feet diameter or 8 feet diameter?
I think they're 7-foot diameter. Is that correct, Randy? I'm almost positive we ordered 7s. We'd probably have to look back.
We purchased them from Rocket Man parachutes out of
Oh,
Minnesota.
okay.
And
Yeah.
I believe they're 7-foot, Mike. Let me go
Yeah.
grab one. Look.
Yeah, I'm almost positive that they are. All right. Well, I'm gonna let Janie start her presentation, but I'm not going anywhere. I'll stick around here till the end. So if we have more questions that come up,
Okay, sure. Thank
we're
you.
more than happy to answer.
Thank you.
But yeah, but great questions. Good conversation.
Thank you. Yes.
There we go. I'm Janie Pallas from the University of Bridgeport. And we wanted to talk a little bit about what to expect because, you know, if you've gone through the annular eclipse, the total one is going to be somewhat different. And we wanted to sort of talk about a couple of just logistics things. And I recognize people from the 2017 eclipse on the call, but maybe some of the students haven't been. And so I wanted to mention that. So one thing is if you are, that's our team from Bridgeport and our student lead who's on here, Hui Huang. But if you have not been to if you're not going back to the same location, you know, you're going to have to wire yourself again for, wildlife, plants, tarantulas, which we had in Texas, which we hadn't had before, and had to sort of, clear out cactus and things like that. So you know that you're going to need a little more time if you're going to a different location. But the other aspect of it is to remember that at least for those 3 or 4 minutes, it's going to get dark. And where you might not have, needed lighting, maybe you want to provide lighting. I know that our team, the mentors, all wear the little helmets with the lights on them, like they look like they're miners, But so maybe keep that in mind. And I think we just found this little video. And I think one of the things maybe to remember is you're going to be very busy, but it would be good to have someone designated perhaps to remind you to look at certain instances, right? This is not going to happen for another 20 years. It's a really unique experience. And I remember 2017, all of a sudden, people were shouting, please look around. If you turn yourself in a circle, you'll see a sunset, in all directions. So I think that having somebody and to remind you at some key points to look, if you were at the annular, that even though it didn't get very dark, all of a sudden you probably heard the crickets come out. We did. And birds had a different flight path. They were just sort of zooming around. But I wanted to mention some of the other things. One of which was, depending on where you are, the traffic. We're going to be down in Junction, and although Junction is not going to get this kind of traffic, Mary Bowden also reminded us that where she's going to be, the eclipse is going to be more at 2 o'clock in the afternoon, right? You're going to have your balloon coming down, and whether or not you will be able to recover that afternoon, right, is dependent on where you are and what your traffic situation is. At Junction, Texas, which is not very close to San Antonio, right? It's north of that. It's not so much that we're expecting tons of traffic, although the sheriff's office have said more than once they're expecting apocalypse. But at Junction, Texas, there are very few roads. So if anybody is up there, you may have difficulty moving around, especially right after the eclipse. So you want to maybe consider that for when you're going to recover. Another aspect of it is that people will see, if you're in a public space, they're going to see your balloon, and you should expect people are going to pull off the road and watch you. They might approach you. So, things like those possibilities should be kept in mind by your team. We are looking at maybe working, we worked with the Sheriff's Department last time in Texas. They were all very, very helpful. Mary Bowden has worked with game wardens in terms of going on property for recovery. So I think that we're looking at working with law enforcement in case we feel that we might need an escort to get out there in the morning. It just really is depending on your location. But if this is a new location for you, different from what you did in the annular, might want to be just cognizant of that issue. Also on recovery, everybody has done recovery now, but maybe, again, just be cognizant of the lessons that are in the NEBP information about going out to do a recovery. In Texas, I can tell you, they told us that 90-something% of all land is owned. And if you look at the maps where we are in Texas, everything is fenced. So it's not a matter of saying, seeing it in somebody's front yard. Everything is fenced off. So unless it lands in a public space, you are, reverse engineering from the location, what the address is, who the landowner is. And as we mentioned, you can't, in Texas where we are, we can't even get to the front door. Everything is gated. Everything is, sealed off. So in that case, like I said, law enforcement was really helpful to us. We gave them the coordinates. They contacted the landowner for us, who was very helpful in terms of us recovering our payloads. So just wanted to mention some of these things which might be very different for this eclipse than the other. Your lighting, right? The time of day that the eclipse is, whether or not you will be able to recover that day, and how you want to plan for that. We did have to hire an arborist last time, and there'll be 2 atmospheric science and 3 engineering teams at Junction with us. And I know we're inviting back that landscaping group. They were very helpful. We had to leave, and they even took it upon themselves to mail back our payload once they were able to recover it. So something, just to be aware of, maybe some additional logistics, and being cognizant of potential crowds that you might have, curious lookers on, and but and also to remember to tell your team to look at these key times during the time of your eclipse, which is very short, right? So that's all that I wanted to mention. Yes, we put down, right? I have to tell you, everybody was watching our payload come down, and it was acres and acres and acres of grass, manicured lawns, and it lands in the one tree, as always, right? But it always does. So, yes, so the owner actually wanted to try to get it down. This is taller than it looks. Couldn't get the whole payload down, so we hired an arborist who went out and worked with that landowner and got everything back for us. So that was what I wanted to share. So
Yeah, I guess I'll just add a couple of quick things here too. On recovery, a couple of things that we found, those sources of information, when we're trying to get a landowner, and like Janie said, sometimes you can't get to the front door of the house because they're just on acres and acres of land. The local post office has worked well before, and particularly like in a small town. That's somebody that kind of knows everybody in town, knows all the addresses. We've stopped in there and been able to get phone numbers and or even that in one instance the woman at the post office made some phone calls on our behalf, and that was able to get us access. And then the other place honestly is just like a local bar or restaurant, again particularly in a small town. You can kind of go in there and everyone sort of knows everybody, and that's a good in. And in both of those cases, what it did for us is in a small community, the call goes out pretty quick. Hey, there's some kids in here from the university and they're trying to recover a balloon. And it was nice just to have a heads up. The whole town knew why we were there and what we were doing. And it made recovery really easy. When we did finally have to show up and knock on a door, they already knew we were coming and they were happy to see us. And it was really sort of a non-issue. So yeah, don't be afraid to kind of reach out to some of those local community places to make those contacts.
we did a volunteer fire department as well, that was in the area where our balloon had landed at one point. So yeah, Mike's right, the local resources and yeah, small communities, people are curious. All these landscapers, all these law enforcement people in Texas were very helpful. And maybe one other thing to keep in mind is some communities, Junction is one of them. The public schools are going to be closed. So that's for two things. One is for, outreach, and the other one is as a potential launch site. Their parking lots, if the school is closed, may be emptied, and you might be able to make arrangements ahead of time. We were on the side of a road last time. Not sure that is going to work for us, so we're all doing a little scouting ahead of time. But public schools, I think Mary Bowden has used that before, when they know there's going to be a school closure. So.
Okay, and we've got a question in the chat from Kevin. Kevin's asking about the size of the diaper. We actually make those ourselves. And I believe, I don't know if I know I'm in my office across campus, but I know Randy's sitting with some of the interns. If they haven't already, we do have a CAD file for that we could post. We cut ours out with a CNC laser cutter, but you could just as easily do it with a pair of scissors. The accuracy of the diaper is not super important. It's just nylon, like kite material, basically, that you can get just from Walmart or from any fabric store. And then we do put some grommets. Initially, we just cut holes in the fabric and ran the rubber bands through the holes, but there's too much tension between the rubber bands and the material, so you do need some grommets. And the grommets were just grommets that we got from the hardware store. It's something that you can pick up locally at your Ace Hardware or any small hardware store.
So here's a picture of it, Mike. Gino went and got this. It's got the grommets and whatnot. But we can sure post this up. I'm pretty sure it's up there.
Yeah, I think it is too.
Thanks, Kevin. Just to go back to the parachute. This is the Vanna presentation of the parachute. It is a 7-footer, and I'll zoom in here. I don't know if you can see that, the label. Anyway, it's a SpaceX 7-footer from Rocket Man.
Any other questions from the group? Again, on anything, this is supposed to be a catch-all, so we have the topics that we've covered, but can't guarantee we've got the answers, but I think between the crew we've got here in the room, we can probably answer most of what you're going to throw out at us. And Randy said he can answer anything that I can't answer, so absolutely anything. That's what I was told.
Not true, Mike, not true.
They're asking if the template's online. It would, if it is, I think it would be lesson, I'm doing this from memory, but I think it would be lesson 8, where we talk about the parachutes and the parachute packing.
I know it's on the computer just in the other room if the file is needed.
Yeah, I've got 2 computers running here. I'll pull up the website really quick. I'm almost positive it's in lesson 8, but I'll make sure.
Because it's definitely on the computer with the laser cutter.
Yes.
Someone wrote in
so
the
it's
chat that it's there.
Yep, it's lesson 8.
Mhm.
There is a CAD file there for the diaper. So if you go to the engineering lessons, you go to lesson 8, payloads and ground stations, and then at the bottom there's it's the parachute packing and recovery section, and then just before you get to the green box, there's a DXF file and a SolidWorks part file that you can download. So if you wanted to go right to your laser cutters, you got the DXF file, or if you were just, again, you could print that out on a sheet of paper. It might be a little bit bigger than 8.5 by 11 sheet of paper, but you could print it out and then just cut it out by hand. Okay, good. Looks like, all right, Kevin, looks like you found it. Awesome. I'm scrolling through the chat to make sure we didn't miss anything. And Randy's having too much fun over there. He's laughing a lot, so he's probably talking about me.
You know, Mike, I'm glad to know that you worry about things. Gino and I were just chatting here.
Yeah. Yeah. Oh, and the last piece on that diaper for the parachute. The safest thing would be just to throw that away. All right. So yeah, we talk about the diaper. That's what we're talking about. So that you don't have any extra lines that can get tangled. Our interns have been recovering it with every flight. So we have a string that goes from that to the parachute. So we do actually retain it. And we have yet to have it tangle and cause an issue. But again, we've probably only flown that maybe 3 or 4 times with the line on there. So you have a higher chance of success without recovering the diaper, but you are dumping something into the environment, which we try not to do. So having the recovery line on there does at least prevent that. And like I said, we've been able to do it successfully without it getting tangled. So it seems like it's a non-issue. We still get the benefits of the packed parachute, and then we get the diaper back every time now. All right, I think that's all we've got for you all. We can stick around if there's any more questions, but otherwise, good luck. Good luck at the eclipse, and we're looking forward to see what kind of pictures and videos you all get.
Thank you.
Thank
Thanks,
you.
Nana.
All right, Janie, I think that's it.
I'll stop the recording and sign off then. Okay.
Well, thank you for